Test, test. Looking good. All right, looking good. Okay. There's some sort of high-pitched whine here, which is super annoying. There's some sort of high-pitched whine coming out of here. It's very annoying, but I don't know if there's anything I can do about it. I don't know if you can hear it. I can hear it. Yeah.
Oh, yeah, yeah.
I turned off the screen, but that did not help. It's not coming from that. It's coming from like some device or to this. It's definitely like, pretty sure it's one of these, but I'm kind of hesitant to just like turn it off.
Yeah.
I don't know, you just, I could just pull this plug and see what happens. That did not do it. Then it must be this one.
Power to TV. And that is close enough to the camera.
Well, all right. That killed some of it.
Yeah. That.
Yeah. All right. I will plug this back in later. I killed half of it. I wonder if there's another one over here.
Probably.
Oh yeah. Totally.
Yep.
Got 'em. However, I wonder if that means that these are not working until the current is. What? I will plug those back in, but I hate those. Can I get you to, or can either of you, to test a laptop on this real quick? And then we'll.
How are you?
How are you? I'm just gonna do this.
Are you presenting?
No, not tonight.
Okay.
I'm going to.
You found enough people.
I'm going to help somebody else
yeah.
from Australia, or sorry, New Zealand. Yeah.
Hopefully.
Next talk is going to be on Peter.
I was gonna check this and see. Okay. All right. Yeah, go for it. Try it. I was just straightening out the camera after I plugged it in. And this is just my speaker notes. I'll just put these right here. Do you have audio coming out of your laptop during the presentation?
I could, but if it doesn't work, I could call a phone number.
What?
Because it's a voice chat bot.
Oh, okay. No, I can make it work.
Oh, okay.
I mean, it should work in the room, but I will make sure to capture it also for the stream.
Awesome.
That's the key thing. That's on. Yeah. And then this is the plug you want to plug in, probably on the other side, I guess.
I think it's here.
Oh, is that it? No, you're right. All right, I'll hand this to you. I'm just going to make sure everything comes in okay. coming in there and you're coming in on the thing behind you. That's the most important thing.
Cool.
And then I was just going to test the full HDMI. You're coming in there. And then do you want to test the audio coming out of the computer real quick?
Sure.
Jeremy.
Yeah.
You said 20 after?
Yeah.
They're ETA? Okay. Who's late?
Drake.
Oh, okay, that's fine. I'll go back after about 20.
Not one of our speakers. So let's see. But we do have David. Let's see. He is. Now I can see David. Yeah. So
I think we have everybody here, right? Was that Fae?
yeah. Or
Yeah.
sorry, I haven't seen Faye tonight. So
Okay.
we have Ray.
I saw Ray and David Neal's remote.
David's remote, and
Andrew's here.
also looking at about half an hour, so in 20 minutes, 10 minutes.
Can I assist you quickly? Defaults?
Oh, something happened there. That's how it's supposed to work?
Yeah.
Let me just make sure that the audio, would you play it again just to make sure that the audio's coming in here?
What assistance can I offer you today? Or it's something you might ask.
It did come over. It did
Yes.
come over. Yeah.
Okay.
I think it's okay. So okay. So I think the key thing is on your settings. Well, I mean, it looked like it was coming in, but whatever you set your audio to, it's coming out over the HDMI. So
Okay. I wonder if it's picking up on my voice.
the voice. So this projects to the room. This projects to the stream. This microphone
I
clip-on does that. Your computer probably won't do that.
Hmm.
All right. I think we're in good shape. I'm
Hello.
gonna try to.
Hello. Hello. Can you hear me?
Oh wow! All right. All right. I'm gonna try to rally the troops who are outside, and you can leave your laptop up here, but I'll probably do intros first, and then you'll be on in like 10 or 15 minutes. Is that
Am
okay?
I? Oh, okay. So I'm first.
You can be.
Oh.
You want to be first?
I
I have you scheduled first.
Okay. Yeah.
But you don't have to be. I would move it around.
Doesn't matter. Yeah. Get all orders.
One, order date 2018-01-02. Time 10:56:33. Customer ID 3777. Product car media players. Sales $140. Discount 30%. Profit $46. Shipping cost $4.60. Order priority medium. Payment method credit card. 3. Order date 2018-07-24. Time 20:41:37.
Yes. Okay. So good. All right. Yeah, there it is.
You can, man.
Commencing execution.
Jeremy, I saw Faye. We're in good shape.
Sweet. David's on. I am currently 10 meters from the podium. So, David, or Dean.
Oh, Dave. All right.
Can I plug? Where can I plug this?
Yeah, you can plug. There should be a plug in there.
Okay.
You can do that.
We were trying to figure that, let's see, how if you were looking to come in 30 minutes or something like that. So, but
Okay, I feel like rally these people.
what's the? Oh yeah. Let's see. We can. I know that there's a speaker order. Okay. Generally, it's the order that we put on the meetup page. Unless there's anything else. If you wanted to speak last or something, then we would take that into account right now because you've got a time zone difference.
Rally the troops, rally the troops. Yes. I mean, I'm expecting. Like everybody wants to like socialize and stuff, and you know that's an important part of the meetup too. I know. I saw her out there. I was like, I'm gonna be a girl in like 2-3 years.
Let's see. We don't have a very good time. What do you mean?
I haven't seen Jorge yet.
Sorry. No. It's okay.
He doesn't always make
You
it.
don't
He's
need to know
usually
how
here.
long it'll go. It's fine.
Where
we're a
it's
business
not plugged in.
affiliation. This is
Oh, is it not? You're not getting any power from it? That thing? Oh, it's not plugged into anything. It might be
Cheer
this.
you up the stage. Shut down the power. Yeah. Let's see. We limited it to 30 minutes.
Okay. Would you maybe try this one? I wonder. That one is on for sure, but there may not be any space on it. And it's taped down, so you can't actually like do anything here. Fuck.
Hopefully it'll last. How many minutes is it?
Sorry.
It's alright. I got an hour, so I
Oh,
think
okay.
it'll work.
You'll just be first and
Yeah.
we'll make it work. Yeah, I don't know why this isn't working here. But okay. All right. Well, you'll be first, and then the laptop won't die. That's what we're gonna do.
Yeah.
That's the plan. All right. Well, not everybody's in, but because there's actually a lot of people out there now. It was a good 25 people out.
Okay,
Maybe
I could
20.
use the bathroom too.
Yeah, you're good. You can just leave everything and I'll. I'm gonna switch over to the other camera, and we'll get started. Full count. Okay. All right. Here we go. All right. Are you okay if I just like close this a little bit?
Or yeah, I could take that.
Okay. Yeah, that works too. Okay. All right. I'm glad you're here. We're gonna get started. There's more people here than I expected, but I guess there was more people signed up on the meetup than like the past meetup, so that's a good thing too. Anyway, you're here for the San Diego Python meetup. Hopefully that's what you're here for. You're in the right place. I'm David. I'm one of the organizers. I want to say a couple thanks to the people who allow us to be here. So thanks to Qualcomm. They're the ones who provided us with this awesome venue to host in, and great AV setup and all that kind of stuff. And specifically like the engineering development team there, which is like they're the team that I guess at some point this comes out of somebody's budget somewhere, even though we don't really spend money, but I'm sure there's some accounting for this. So I want to thank them. And then Drew and Urivan are kind of my contacts here, and they're extremely helpful in just making sure everything runs smoothly. So I just want to say thanks to them. And thanks to Jeremy, who's sitting right there. He helps wrangle all the speakers, so we have speakers at the meetup, which is awesome. That helps me a lot. And I want to thank Neo4j. Neo4j is, they provided the pizza for the meetup, so if you had the pizza, that's thanks to Neo4j. They provide a graph database that for certain types of operations can be orders of magnitude faster than a traditional relational database. You can download it and run it yourself, or there is a managed version in all the major clouds, so you can check that out. All right. And then I have a couple announcements, and then we'll just dive into our first speakers. There aren't too many announcements, actually. So there's a Saturday meetup, which meets Saturday. It's virtual. It meets on Discord. If you don't know what the Discord is, you can go to sandiegopython.org and find the Discord. And all the info to get it to, the time, it meets at 10 a.m., but all the times are all on the meetup page and on the website. And it's a little different than this one. There won't be like a speaker lineup or something like that. There won't be pizza because it's virtual, but sadly. But it's a little different. It's more of like you're on your laptop. People are discussing the projects and the problems and things that they're working on. So it's a different vibe, but very much a part of San Diego Python and super cool. So if that's your thing, you can check it out. Just show up. It's 10 a.m. virtually on Saturday. I did allude to it. We have a website which has a code of conduct, sandiegopython.org. If you want to get involved in building things on the website, that would mostly be me, who you'd probably interact with. But everything for the website, to run it, to host it, deploy it, everything is all on GitHub. And there's people on the Discord happy to help you if you want to get involved. That would mostly be me also. There's a YouTube channel. The meetup is streamed to YouTube for people who cannot make it, or who, there are people who can't make it, but who, can't make it for a variety of reasons. Anyway, it's youtube.com/@SanDiegoPython. We stream all of our meetups. So like if you come back 6 months and you're like, oh, I forgot about this speaker who gave a talk on whatever, but I know it was in May of 2024, boom, you can go back and just check it out. I said the Discord, which you can get to from the website. And then I do want to mention upcoming conferences and events. PyCon US, it'll be, actually I didn't write down, where is PyCon this year? It's in Pittsburgh again. I don't know why, I didn't write it down. It's not in my notes, so I forgot. Yeah, I've got the dates. It's May 14th to May 22nd. And you can check it out at us.pycon.org/2025. But for some reason, I didn't have the location on my notes. That's a fail. I'll fix that up. And I did want to talk about the most important thing on the entire website. It's now a big button, or bigger than it was, but it's a button on the website, which is signing up to give a talk at a future meetup. The most important thing on the entire website is signing up to be a speaker at a future meetup. I am very incentivized, and so is Jeremy. We are highly motivated to find speakers for the meetup, not only because speakers kind of make the meetup work, but also when there are not enough speakers. Either Jeremy or I have to give a talk on short notice. So I'm very motivated to find speakers. Speakers at all skill levels are great, whether you want to give some advanced talk or some talk on the problems you had setting up your Python environment. Literally, we're looking for 7-minute talks. You're not going to bomb. We have a 100% survival rate. Every speaker has survived. You can do it. Don't feel you can't do it. Your talk will be great, and I'm looking forward to it. So please sign up on the website. Awesome. And I think that's it. I think our first speaker is Andrew. You're first. Andrew Buensalida is going to talk to us with a voice chat bot. All right. Take it away.
Cool. Yeah, how's everyone doing? What I'm presenting is basically a ChatGPT clone. A little bit about me. I've been building projects for about 5 years. And I guess let's jump into it. It's basically under the hood, it's OpenAI ChatGPT that answers questions. I gave it dummy data, some musical instruments. I don't know if the sound system will echo too badly into this, but we can try. So for example, get all orders. So it's either you could type into it, or you could talk to it, or you could even call the number. So this is typing into it. So first it has two servers. So first it hits the first server, and then it hits the second server, which right now it's just a CSV, the musical instruments. So that's an example of text, or you could even, let's try the voice.
What may I assist you with? What assistance may I offer?
Get the cheapest guitars.
Really speedy. I'll get right on that. Got it. Working on it right away. The cheapest guitar I found is a string action gauge ruler guitar Hayu gauge setup tool priced at $7.99. However, it looks like this is actually a tool for guitar setup rather than a guitar itself. If you're looking for a playable guitar, there's a glary full-size electric guitar for beginner with amp and accessories pack, priced at $95.98. Would you like more information on this guitar?
So yeah, I prompted it to talk fast because like when you're testing it, you kind of talks over and over again. You just want it to say the thing really quickly. So, but aside from the voice through this website, you could call this number too. Under the hood, calling this number hits a Twilio, which like connects WebRTC to my backend server. So what else can it do? Recently, I put in a decision tree. So like even you could think of a use case, maybe like a medical decision making thing. So for example, I only did this part of the tree, but this is trying to figure out what musical instrument I should learn. So let's try it.
What assistance do you require?
Help me choose a musical instrument.
Got it. Working on it right now. Do you want to be taken seriously?
No.
Sure thing. Consider it done. Do you like jazz?
Yeah.
Executing right away. You should pick the trombone.
There you go. So that's that decision tree. So like you could think of like medical applications or like doctors deciding what disease a patient has, or yeah, there's like any type of use case, any I'm trying to make it anything a human can do, trying to make it do. So so that's that. Did you guys want to, I guess I could show you the design diagram. So it uses, for the streaming, it uses, so if I'm typing it into it, it uses WebSockets to get a stream. That's because if it's not a WebSocket, if it's like a regular REST API, when you click send, it'll wait until the whole response is done, and then it'll send back the whole response all at once, which is not really the same experience as ChatGPT. ChatGPT, it streams like one word at a time. So I think that's a better user experience if the user could see the response streaming in right away instead of wait a long time and getting the response all at once. So that's the use of a WebSocket. For the speech, so it uses WebRTC for the speech. It first makes a connection to the web server. So step one, when the mic button is clicked, and then every time the user speaks or the assistant has a response, that's saved to the messages CSV database. So it persists. So like even if I refresh the page, it'll persist. It's still there. Actually, you guys could even go to this site, demo.ai@yourservice.com. You guys could try it out. And then, so yeah, every time there's a user speaks, it creates a message, and that's sent to the OpenAI, and the OpenAI gets all the previous messages and makes an inference and makes a response. The response could either be like a regular response if it's done responding to it, but if it's like it could also have a function calling too. So, for example, when I said get the cheapest guitar, that's a function call. So it knew, okay, I need to call this function to get search the products database from Pinecone, which is a vector database. And then once it gets like the 5 most similar guitars, that's when it sorts it. So it does a semantic search first, and then it sorts, and then it brings it back to the OpenAI, which again creates the inference. So it's like it's a loop. And then for the Twilio, if you call this number, how that works is, so you hit the Twilio server, Twilio hits my server, and it does like a 3-way WebSocket. So the audio chunks come from Twilio, and then it gets received in here, which I then pass it along to OpenAI. And then when OpenAI has a response, the audio chunks, I pass it back to Twilio. So there's like a 3-way WebSocket thing going on. That's pretty much it. Do you guys have any questions?
So when you get the first input from the user, let's say typed in, first of all,
Mm-hmm.
do you first go through Pinecone and get it? Because I don't see an arrow coming from Pinecone. Does it go with the is that joined with the prior messages and sent to OpenAI, or where does the arrow go from? Oh, it goes back up to Heroku Fast API, but then where does it go from there?
Mm-hmm. Yeah. So that step is 8B. So after 8B, it goes to it saves that the results from that Pinecone, saves it, and then that's step 9, and then step 10. Yeah, it sends all the previous.
So it sends your lookup through what you think would be a good match to the question. Once you go through Pinecone to find out like the trombone is the right thing, and then that is then joined with the response over to OpenAI in order to get the response.
Yeah.
Okay, now
It's just a prompt. Just prompt it. Say talk really fast, and
That's it?
that's it. Yeah. OpenAI. Yeah. You could even tell it to talk in accents or whatever.
Frequency that you wanted to come up with, or just like regular fast, medium, low?
I don't know if it has like a spectrum of speed, but that's pretty much as fast as it goes. Yeah.
I have a question on the responses. Did you script some of the responses, or how much is it coming from OpenAI?
So, for example, which response?
So just some of the responses that are kind of funny, like, hi there, I'm Samantha, whatever.
Uh-huh. That one's OpenAI. I just prompted say, okay, well, here's I'll show you the agent, the prompts for the agent. So here's the prompt. So
Yep,
name Samantha, the tools she can use,
gotcha.
and then this is basically it. The prompt. You're a helpful assistant who speaks really really fast. Help with datas and products. That's pretty. And then, so when the microphone button is clicked, there's a prompt saying introduce yourself, and then it already introduces itself.
So that dictionary that you just showed us, I'm sorry.
Mhm.
Okay.
Is that a standard dictionary that you use for interacting with OpenAI?
This it's a combination of like following the documentation. So, I think I followed the documentation with this
So
one.
the voice is Sage.
Yeah.
So is that the particular type of voice that you have, that sort of cute little voice?
Yeah, that's a female
I might
voice.
actually reprogram mine to do that because it's so much fun.
Yeah. Yeah. Sage.
I have a question.
Uh-huh.
So one of the things, well, it's freaking great. One of the
Thanks.
things that I can see, because you were talking about the applicability of this application to other industries. I mean, you can even use it as an AI sales rep, really, right?
Mhm.
Because if you can get the AI system connected to the supply database of a particular store, right? And if someone is utilizing your application, then and plus if the model is fine-tuned or even trained on be able to take some of the input from the user to find the specific like descriptors of an item that they already have, then they can become a really good suggestion of particular products according to um, the language that they use in that input. You know what I mean?
Mhm.
One of the things that I did wanted to ask you is, I know you mentioned that you were using CSV as
Mhm.
I suppose that's the basis through which then the conversation gets vectorized to the model, right?
Mm.
Because basically the model has to embed the information that it takes from your voice, right?
Mhm.
And then be able to use that in order to analyze all the information. Have you tried to use JSON instead of a CSV file? Because I found out that sometimes when I use JSON, it's better at processing that information.
The CSV, this could be anything really. It could be JSON, it could be SQL. It's just a database, whatever can do CRUD, create, read, update, delete. You could use whatever. But for Pinecone, um, I use that for the function. So, for example, when the user says get the highest rated guitar, that's when I use the Pinecone. So
What is Python?
Pinecone is a vector database.
Okay.
So it converts it converts. I think it it does guitar, and then it converts the word guitar to an embedding, and then from that embedding, it searches Pinecone for what's the most similar item.
So another question: why did you choose that particular vectorized database?
Yeah, because it's in the cloud already. It's already managed. I did use the other one, like the local. I think it was Chroma, but if it's on Heroku, Heroku is not fast enough, at least for the free version. So um, it's just easier, Pinecone. Oh yeah, yeah. Decision tree. So that's the decision tree. It's just nodes. So there's a tree node. Initialize it with the question, and then if it's a yes, it points to another node. If it's a no, it points to the right node. No, it's not an embedding. It's a tool call. Yeah. It's one of the tools that Samantha has. Where's that? Instrument decision tree. The LLM decides. Yeah. So in order for the LLM to know what tools to call, you would give it a tool schema, something like this, a list of dictionaries, and then the name of the function, what type of parameters the function should take, if any of them are required. Yeah. Any other questions? Oh.
No, now that you bring this up, how does this, even though you give it the function name, how does this program call that function name?
Yeah. So the LLM, let's say the LLM decides, okay, the user wants me to do the instrument decision tree. So it responds with like a tool message. So execute.
So that would import a library and basically call the method with the given arguments. Kind of like a get that there call, or
Well, in agents, you can see it's actually a callable.
It's a callable, yeah.
So it has to do with the OpenAI library that you imported, and it's just calling, it'll trigger something within that, so that will call our function.
Yeah, here it is. So for example, if the LLM responds with a tool calls, if there's like tool calls together in the response, I check that. So if the finish reason is tool calls, it goes into this and it executes the tool. I execute it myself.
So you basically look up in this, like a list of dictionaries or whatever you have over here for the section of that name, and then
Yeah.
you pass that to the LLM to process?
The LLM doesn't run the tool itself. I run the tool.
Okay, you run the tool, but there's a lot of things in it that looks like you pass those things to the LLM to process.
Yeah, like the definition, like what sort of parameters it has.
Okay.
Yeah.
Very interesting.
Correct me if I'm wrong, but OpenAI doesn't hold state. You've got to manage the state of the conversation.
hopefully. um, well, for this the voice, yeah, I manage the state, but if it's the Twilio, when you call the phone number, um, I think it does, because
Twilio manages the state.
not I don't think Twilio does. It's real time.
Okay,
It's open AI.
okay.
They somehow keep the state of the conversation in a thread. I don't know how long they keep it.
I know that between threads, there's no state count, but
Yeah.
it seems like, to me, they keep the state within the thread pretty well. I mean, it seems to know what he just did, but that's just my.
Yeah.
To cut off the questions, but I do.
Okay, thank you.
Great job.
Okay.
Yeah.
Yeah. Oh, and if you guys wanna, I guess it's too late. But
Is this open source?
No, but yeah, talk to me if you wanna find out more about it, or if you have like startup ideas or whatever. This is my LinkedIn.
Cool, thank you.
That's true. I asked it how many.
Now there are a ton of questions. Sounds like everybody's really interested in this. Just gotta move to the next speaker and have people talk about it after. All right, awesome. Fae Gaze is our next speaker, and Faye's going to talk to us about language models, LangChain, and GraphChain. You want to come up? Oh. Okay, I lied. Well, my notes were totally wrong. You're talking about something else? You want to talk about something else, though? Okay. Okay. I'll let you say it, because my notes are totally wrong. That's okay. It's fine. All right. Come on down. Hopefully, you just plug in and it works. You have. Okay.
Yeah, it doesn't.
Yeah. So what we need to do is this goes into here, and this goes into there
thank you.
somehow. Very carefully.
Yes.
All right, and then hopefully just things come up and everything works. Do you have? It came up. You don't have audio coming out of the laptop. Do you?
Yeah.
No. Or yes.
Yeah. No.
Okay, then you're perfect. Should just work.
I think.
Okay. It's probably on me. Okay. Take it away.
Hi everyone. Yeah, today's topic, I just wanted to talk about object detection and segmentations. So a little bit about myself. I've been working in medical data analysis for almost 8 years. So this topic is focusing mostly on the brain tumors. So the reason that I do choose brain tumors is because it's the most critical and complex medical conditions that it's causing lots of mortality rates during just every year. So that's the reason that this topic, and it's very important that to locate exact section of the brain with the tumor and also to mask it. So both for the bounding box and for the masking. So the problem statement here is lots of those medical image analysis is manually. There were some experts that they were doing it manual and or using the pre-labeled data. But the most important part is to use And this part is the manual process. It's very time intensive, and it's also prone to lots of errors. So that's the reason that it's important to use automated solutions. The goal is to have an advanced deep learning model that can assist in automating and enhancing the accuracy. So this is the data. This is a medical imaging data, MRI, from the brain tumors, and the data is publicly available. It's I found the data from RobotFlow, and these are the Grant Ruth pre-labeled that they all have tumors, meningioma and glioma. So these are the types of tumors. And also they have 5 tumor classes that it has also pituitary and also no tumors. So the pre-labeled data and the need for the object detection, as we talk about it, is to minimize the false negative errors. That is a very important part for the increasing the recall. And the recall is for the cancer detections is can be very life-threatening. So that's the reason. And also for the data noise and this part. So that's the part that it takes us to some automated methods. So the data, these are all explanations and the challenges that I personally face on this project. When I get the MRI medical imaging data, the data was in this structure of object detections. And when we wanted to do segmentation, it's totally different data. So the point is, I personally built up the data structure again because the labels from this data and another data and another part methods for the object detection and segmentation is so different. So it's lots of algorithms involved here because for every image, for every medical image, it's creating the text data. And the text data for the object detection, it's mostly about the coordinates of the bounding box, because that's the output of the object detection. And that coordinates can go to the different parts, minimum, x minimum, maximum, and different parts. But the labels for the segmentations, it's going to the every pixel levels. So it's giving out the binary images, and after that binary images, it goes to the exact locations, as you see that these are the tumor locations, and from that it used the geometry sections, and that's the difference between the labels between these two methods. So they both object detection and segmentation, they have a pros and cons. For me, in this project, I use the combination of both object detection and segmentations because I could get the output of the object detection, that is a bounding box, and give it as an input to the segmentations. So the segmentations is providing the masking for the tumors. So how we can identify that which model is the best? When we do a medical imaging for this, for example, how we know that which object detection has the best accurate results? For that one, I use the matrix. The matrix is F1 that I use it for the, that is a balancing between precision and recall, and also another matrix that it's IOU, intersection over union, and that shows that how much of the maskings is overlapped by the ground truth labels. So it shows the overlapping percent. So as you see that here, this is my ground truth label, that it's an MRI image, and these are the images that I provided based on different algorithms and different steps. So I use the detectron, I use YOLO, and I use the more fine-tuning of YOLO. That means that I put the data augmentation that mostly for the rotation and flipping the data and different other changes to YOLO, and that to fine-tune and then fine-tune it to the data. So, and also the most updated version. Here we see that at the beginning, the pre-labeled data is glioma, but detectron is misclassified to another tumor that is completely irrelevant. But for the YOLO, that was another object detection models, it could detect that one and also another tumor that it was consistent with glioma. The problem here, it could be for this mislabeling, it could be a lack of tumor features that the program could not adapt it. So, and we can see that for the future, further, when I did for the YOLO more fine tuning, we have more detections of the tumors. So this is a segmentation comparisons. This is an object detection. So for each of these tumors that it was labeled by object detection, it was a masking. And here we see that the YOLO and SAM, that is the most accurate methods here in this project, it failed. And it failed, it should be, and again, because of the inconsistency to all pre-labeled data sets or insufficiencies of the model adaptations. It couldn't predict the masking, but for the YOLO segmentation and for the detectron, it was detecting the sections for the segmentations, and it provide the masking over that regions. So here we see that these are the bounding box, and here they use the output of the bounding box and then to do the masking with more accuracy. So here it's another MRI image that it has we can see that two tumors together. And when I created the metrics for the object detection, F1 score was higher for the fine-tune, the most updated version of YOLO and SAM. And that's giving me a, based on that, we selected this one. The program itself selected that image. So for the segmentation comparisons also, it's going to the metrics, and based on the that IOU score, it gives this YOLO and SAM. We see that all of them, they have two tumors detections, and the confidence level is different. Some of them, they have a higher confidence level, even YOLO segmentation that have a higher confidence level, but still because of the overlapping regions for the masking and the ground truth labels, the metrics is decided to give this one as the best, most appropriate method. And here, as we see, another for the another MRI, and unfortunately, detectron, we see that it's failed again. But for the YOLO and for the fine-tune YOLO, we see that it works. And even for the, when I did changing the hyperparameters and also augmentations, I saw that there are more tumor detections that we see on the free, that now it's capturing 3 tumors, and they are all gliomas tumors. So, and this is the one that YOLO and SAM the combination of both providing a better results. And detectron failed. And the same as here, that even they have the same confidence level for the YOLO segmentations and for the YOLO with the more updated augmentations and updated version. It's still because of the metrics, the program decided to choose the fine tune. And this is again the segmentation of the fine tune. We see that even the program for the objection detection is selected that one, but for the segmentation, here it's creating the two tumors. I wanted to mention that it's based on my challenge of this project. It was these regions of the brain and then going to all of these methods one by one. It's all about building up the data structure from scratch for all of them. So to show the exact regions of the brain from the exact data. So this one also, we see that even for the YOLO 11 and more fine tuning, they have the same score, but again, the program chose the further fine tuning, and the same as here. Here, it says a very interesting sections for me, because on the right side, we see that the program chose the YOLO and SAM because of their high metrics score, but I personally chose the detectron because it was able to divide the tumor to two different tumors. So it's not one tumor.
Last time. Sorry.
No.
Yes. We're apparently not moving enough.
Maybe.
That's funny. Jumping jacks between boxes or something.
Stand up.
The lighting switched to off.
Put on one of those
I think it probably
timers.
just was the time, 8 p.m.
Except in the earthquake.
Okay, it should be back on. Sorry. We got timed out at 8 p.m.
Carry on, carry on. No problem.
Sorry.
Here we see that the detectron 2 was dividing the tumor that the YOLO and SAM is finding the two different divisions. So it's two tumors. That's the reason that it's very important to have the combination of all of these methods together. So the best models, the best method for the tumor detection and segmentations, based on my experiences in this project, is even if the matrix shows me the fine tuning, but it is better to use the combination of all of the methods, because in many cases, as we see before, even the fine-tune method, the fine-tune of YOLO and segmentations failed. So even it has a high score, but it failed. It wasn't able to detect the tumor selections exactly. So that's the reason that it's very important to have all of the methods together. And sometimes detectron failed for some case, but it should divide the exact tumor here to two different tumors in this case. So we cannot really say that one is better than another. We could just apply all of these methods, especially this case is very life-threatening, and it's very important to provide the better results to those medical professionals and radiologists for the cancer's progressions. So for the next step of this project, I will be mutations and compare them together to filter exact part of the tumors, and also refine the annotation and provide more external data and more pseudo labeling data to improve the accuracies of the recall here is more important, and minimizing the false negatives. Thank you. Any questions? Yes, please.
I do have a question. Is your methodology currently being used in any radiology department? Or
SAM is the most updated SAM is, I think it's arrived about 4 or 5 months ago. I saw different research papers that use the YOLO object detections and SAM segmentations together. But this data and these methods that I use, I didn't personally see it exactly for these images and this part.
so it's not generalized in the industry yet?
I think so, because I saw it for different areas of the medical imaging, but not for this part. This one, I just received it from the public data available in Robot Follow, and then I did my analysis. Yes, please.
Great talk, great approach. Have you tried using Napari or checked out image.sc's forum? Because there are some people recently working on YOLO and brain imaging. So we could talk after. But I liked the talk and I liked your approach. So you're on the right track.
Right, exactly. Thank you. When I did a YOLO segmentation, they only focusing on YOLO, right, Napari?
On what?
The website that you mentioned is focusing on YOLO or YOLO and SAM together?
Actually, it's a 3D visualization modeling program that came out of the Scikit image team and Chan Zuckerberg initiative. And so they're looking at primarily brain mapping and modeling, but also it's being used in mechanical science, material science as well. So happy to chat more later.
Yeah, exactly. That's interesting.
Very cool.
Is there any other questions?
So you're talking about building up data sets is the hardest problem. So,
Yeah.
If you were going to build up the data set for a 3D model instead of just the 2D slices, or let's see, does it already take that into account, or is that a completely separate problem?
These are, it was a 3D images, all of them, but it was cutting different slices. So for the 2D images, when we put them together in the X, Y, and Z directions, so it's gonna be a 3D images. So the approach of the image processing is different because that needs to build up the models that it can go to 3 different directions.
But you can build up the layers or one line of each slice and build a side view of brain. And so you can do this, let's see, do each one of these algorithms on the side view of the brain. And does that give you a different a view of, let's see, this same problem? Let's see, be able to find the different types of cancers?
That would be considered, yeah. It could maybe improve the recall, or it may affect on that. The metrics level, mostly the statistical metrics. But also data augmentation, they could be also considered as that it could go to different like rotations, flippings, or
Following up on his question, like if you look from sideways, can it easier to detect the tumor, like instead of the slices?
approach both directions. So you have the individual slice from maybe a top down, and also being able to see a side view. Putting those two together, you can be able to find out XYZ coordinate of a particular point that is problematic.
We could go to the cutting the image. Is that what you're talking about? In different slices.
One on top of the other, right?
Right.
It's a 3D model, essentially.
Yeah, then that's what you're saying, right? Like you see them from one side and also, so you could essentially detect in 3D. That's the question. I think that's the question it's asking.
Mm-hmm.
Is there a model that can engage in that type of 3D analysis? I think that's what it's asking.
I know all of these images, they used to be 3D. But in case this one that exactly go to different models for that,
and
they are slices.
The 3D is made of 2D layers.
Exactly.
Oriented in space. So,
Right.
You can generalize your approach to 3Ds because they're just different layers.
Exactly, different layers. When all of these microscopic images, they're all 3Ds. Because it's not only one image, they get images from different corners. And the stacking of all of those 2D images could create the 3D approach.
So my understanding is that by stacking different images together, it would increase the likelihood of a positive identification. Is that correct?
Yes. Increasing, right.
Cool.
Is there any?
Thank you. All right. Our next speaker is a remote speaker. It's David Neal. He's talking to us from New Zealand. And he's going to talk to us about more than just commas, a data-driven demo of Python CSV library. I'll let you get set up. So don't forget to make the HDMI output. Okay. Oh, yeah. And we can use this thing. Or do you need this thing?
No, I can use HDMI.
Okay. So it's this one.
Get you all set up, and I haven't turned on the audio yet. Extend entire screen. Sure. Start hearing. All right. Second. Just turn this around. Whoops. Well, that's not going to do. That doesn't help. Let's see. Let's see. How do you turn this off? Change.
What are you trying to do?
The background. Apply visual effects. Here we go. Backgrounds. Just not. Yeah. How do I make it go away? Blur background.
Oh, maybe.
Where the 2 is?
And maybe wait, yeah, maybe that. Remove all.
Woohoo! All right.
All right. David, can you hear us? We can't hear you though. He's talking and we can't hear him though, so something's wrong with the audio.
Okay.
I think. It would be with your probably. Well, it could be the audio settings here, or it could be the audio.
Let's try
settings.
this.
Oh, we can barely hear you. What did you say? Oh, that came in.
There we go.
You're just very quiet, David.
I didn't want to.
Oh, yeah, that's what everybody says about me.
Oh, now you're coming in good.
All right.
All right. Should
We might have two audio channels, one in the Google and one in the YouTube.
Did you ask David to talk one more time?
All right. Yeah. Can you, let's see, give a soliloquy.
Mary had a little lamb. Its fleece was white as snow.
Oh,
so he's not. So this is in the Mac system settings. It's in the. Sorry, we're fixing your audio real quick. Yeah, that's it. Okay. Now, can you say something?
Say something.
Hey,
oh, yay! All right. Let's see. Quick announcement. PyTexas. It's on April 11th through the 13th. Let's see. So you can buy tickets, and you can also buy virtual tickets. So $25 to be able to attend virtually. Let's see. Pretty good deal. If you're under 18, it's free. So it's also at a good time to actually visit Texas. It's one of the most livable times to actually visit. And let's see. I wouldn't be there any other time. So now on to our regularly scheduled speaker.
Not talking. You want to tell him to go for it?
You ready to go?
Okay, thank you, Jeremy. Jeremy, can you do a quick look around the room? Tell me how many people are beginners and how many people are more advanced in their Python? Oh, any advance on 15? Right. Okay. Is the image large enough? Is the text large enough? Right. Okay. So more than just commas. CSV library from the Python standard library. Yes, I come from very southwest of Southwest San Diego, and you can swim to visit me if you'd like. This is a beginner talk. Some intermediate people, if they have not used the CSV library previously. So thank you very much to Fae, but yeah, I'm a long, long way below the level that you were speaking. Yeah. Questions to the end, please. Python masters, you will see obvious faults. Please don't yell out and spoil the surprise. If beginners would care to make an announcement or make a suggestion of how things can be improved, then yeah, more power to you, please. Shout it out and maybe Jeremy will relay. You can see already that there's a deliberate mistake. I like to have something for everyone, including the people who look for mistakes. So there you are. The first thing we're going to do is we're going to take a look at a very short CSV sample file, and then we'll try reading the file, making some sort of sense of it. We'll collect the data into identifiers, and obviously in a real life situation, we would use those values in later processing. Eventually, we'll realize that CSV is not quite as easy as it looks, that there are all sorts of shades and grades of CSV files. So we'll concentrate on our file input initially. Later on, we'll deliver it to different data constructs. So the motto for the day: you have to work really hard to reach my level of laziness. Here's our sample CSV file. You can see that PyCharm has very kindly colored it for us. Hopefully you can work out that we're looking at something like a list of products for a supermarket. Right at the end, the yes, no, etc. It occurred to me I could have made that into whether it was an organic product or not. Instead, one of the fashions around here is to talk about how many miles food has had to travel to get to our store. And so we're interested in local produce. So yes, it's local, no, it's not. It's a lot easier to see these, the structure of these things when you look at it in a worksheet. You can see that it's a tabular structure. You can see the columns. You can see the rows. You can see the intersection of rows and columns is a field, which will become a single value. And what have I missed out? Excuse me, wrong way. Right. So some definitions. It's tabular, etc., etc. Add to that delimiters, right? How do we know where one field begins and ends? How do we know where one row begins and ends? Or one record, if you prefer. One line, if we were talking about a serial file in Python. And what about separators? Usually we would use commas, but are there others? And one worksheet in our Excel or whatever we are using, LibreOffice, Calc, is a file, so a CSV file. These things are good because they're easy to read, they're easy to use, they're simple, they're straightforward. They have the virtue of being, I'm going to use the word compatible across applications and operating systems. I'm going to see that why I hesitate on the word compatible a little later on. They're lightweight, they're efficient, they're easy to process, they're easy for us to process, they're easy for computers to process. They're an essential part of the Python ecosystem, so it's something that's worth learning, particularly if you're heading in the direction of math, stats, and data science. And last but not least, they are very popular. So once again, it's a skill worth gaining. Let's try reading in a CSV file. So here's our first attempt. I'll run the program for you. And there we go. What we've done is we've read in a line of data, we've read in the next line of data, and so on and so forth. There's only the half dozen lines. And I've put in some extra arrows just to show you where everything begins and ends. So you can see that to the left of the 1001, that's where the string begins. And to the right, you can see where it ends. So anyway, the program's working, everything's wonderful. Everything we're looking at is a string, a single string per line of the file, per row of the spreadsheet. How come the delimiter's on the next line? Any ideas? I won't be. Thank you. I won't be able to hear somebody on the floor, so thank you for relaying that. Yeah, indeed. Don't forget that when you use read lines, you end up with the end of the line included in there, the delimiter. Okay, fine, great. Let's split the files up. We've split it into rows. Let's try splitting up the first row into fields or into its columns. So here we go. We'll have a look at, we got the same splitting up into rows. And then what we'll do is we will split it up into these half dozen fields. And there we go. Right, lovely. Look at that. That's all very nice. Yes, wonderful. Can we go home now? Probably not. What data types are there? Right, the fields and the identifiers, they are all of these data values are all still strings. Unit price as a string is probably not going to be very easy to compute. So let's see what we can do about altering the types of the data. So this first field should probably be, well, I'm going to cheat. I'm going to say it should be an integer. If it's coming off a database, I think I'd prefer it not, but let's pretend. So we build this function here. And what we'll do is we'll set the product ID into being an integer. And so if we run this program, oh, this is science at work, I tell you. Yes, we are taking our string and we are changing it into an integer. Oh, lovely. Well, job done. That works. All right. What about the next field? All right, now the next field is, of course, this one here. It's the name of the product. Now that's already a string, and we want it to be a string. All right, okay. I'll just write the function so that we have a function to call, and there it goes. And yes, it works, but it doesn't really do very much. But let's just go with the pattern of work for the moment. All right. Now, what about the unit price field? This is our 3.5 over here. That's going to become a float, right? And I can hear people groaning in the audience because this is really naughty. If you're going to work with finance, please use decimal. But I don't want to confuse people talking about the decimal library who haven't met it. So I'm going to stick with floats, even though you know I'm wrong and I know I'm wrong. And hopefully everybody knows I'm wrong and shouldn't be doing it. Okay, so here we go again. Another function. We're going to take the unit price. We're going to convert it to a float. And I noticed that I've borrowed this from one of my own pieces of code. If it's a blank space, which it isn't, then obviously we would prefer it to be 0 rather than crash. So let's run that piece of code. And oh, look, yes, we've been able to take our 3.5, which comes in as a string, and turn it into 3.5 as a float. Oh, nice stuff. All right, we keep going. The second to last field. Oh, what's that? Oh, yes. This is where life's going to get difficult because that's a date, and dates are a load of fun. Once again, notice that I'm not using US date formats. There's a difference between US and European date formats when you use digits. So I'm using the ISO format, which is a lot more computer friendly as well, because it sorts if you have a string like this. Okay, however, I would like to be able to use it as a date inside my program later on. So how are we going to prepare this data so that it will work? Yeah, we run this program and oh, nice. We've got it as a date time class. I've had to import the date time module if you haven't met that before. And then there's a little bit of complicated work going on here. I'm not planning on explaining this in detail, but we're taking in our string called data field. We know it's in this year dash month dash day format, and we want to put it into a date format that Python can work with. And so there it is as a quick explanation. So that appears to work. And we'll move on now. The final field. Hey, we're streaking away here with a solution. The final field is supposed to be a Boolean. And at the moment, we have the words yes or no. What I'd like to do is translate them to the words that have meaning, or the values that have meaning in Python, true or false. So here we again have another function. And what we're going to do is we're going to, first of all, we're going to strip the field, and that's a bit of a cheat there. Then we're going to adjust it to lowercase, and then we're going to see if it starts with the letter Y. And I've just messed up the code, and good job, PyCharm, thank you. Right, so there's a few things going on there. Once again, don't want to spend a lot of time explaining them. Otherwise, Jeremy's going to throw me off the air. So we will run the code, and sure enough, we've got great success of converting our yes as a string into true as a Boolean. Oh, very good. Right. Yes, wonderful. Well, that's all of the types that we have in our sample data file, our little 6-line data file. Let's try putting it all together now. We've done it one field at a time. Let's put them all together. So here's all of the functions that we developed one at a time. And here's some code to run those functions. I haven't changed any of the code in the functions. All I've done is put it all together. And then obviously in the main line, I've grabbed every single one of the fields. And so bang, there we go. We've got everything running. I've cheated just a little bit by only looking at the first line of our file. Otherwise, there's going to be a wall of text here. And so you can see, yeah, look at that. Apples, yeah, that's correct. There's our integer. There's our date. And there's our Boolean. Oh, great. Yeah, wonderful. Wonderful. Oh, wait a minute. After apples, there's kg, and it's missing. Oh, no, bad news. Right. It should be a string. Now, we already have a string. That's the product name. So we just reuse the function, right? I mean, that's why DN used the function in the first place, isn't it? He's a smart guy. Well, he thinks he's a smart guy. The trouble is that function's called product name. And yeah, that's not a very good name when you're working with a unit quantity. So we already have the code, but it's not appropriate to use the function called set product name because we're dealing with a different field. So what we need to do is we need to generalize our conversion functions. Oh, all right then. Okay, not too difficult. Let's generalize. So now, instead of dealing with the product ID, we will say we're going to convert to an integer. And cleaning a string, right? Perhaps we're not actually converting from string to string, are we? That doesn't make a lot of sense. But we are converting to a float, and then later on date and Boolean. So, okay, the code hasn't changed, just the title, the name of the function. All right, okay. So now let's add our missing field, unit quantity. Let's see if we can get that to run. And oh, nice. Right, there we go. We've not only got our apples, which are a string, but we have our kilogram, which is a string. Once again, apologies to those who like imperial measures. Most of the rest of the world uses metric. Right, it works. Okay. Now, there's a real problem here. It works for my simple little demo file. But will it work for other CSV files? Because CSV files come in what is known as different dialects. And you'll notice that, sometimes every single field in a CSV file is delimited, that word again, by double quotation marks. And I haven't used any double quotation marks in the little demo file. So, there's a major difference already. So there are other dialects of CSV. How well will this piece of code handle different dialects? So here is a very, very contrived file. Now, normally I would expect consistency, particularly in a file that's produced by some other program. I wouldn't expect to see just 1004 as a product ID on line 4 there in quotes. I'd expect to see them all in quotes. But what I've done is I've created a highly destructive file, and anybody who's into testing is going to be very proud of me. Right. Okay, so let's change the file that we're going to use. There we go. We're going to use products2, and let's see what happens when we run the program. And right, once again, I'm cheating a little bit. I'm only looking at the first line just to see what happens. And all we're doing here is we're cleaning up the string just to see if we can actually pull it out. And yes, there we go. We can get things working. There's our apples for apples. Lovely. An apple a day keeps the doctor away, and good health to all. Okay, so yes. What have I forgotten to say? It works all right, but there's some sort of a problem with our product ID. So if we have a look at that, excuse me, product name. If we have a look at that, any ideas what's wrong with it? Thank you. Yes, extra spacing. We really don't want those extra spaces in there because space is not going to sort in the same order as A for apples. So we really don't want to have extraneous spaces. So what we're going to do is we're going to modify our clean string And we're actually going to do some cleaning. So now you can see why we had a function for that. Yeah, as usual, DN's cheating. So we're going to strip, and that will remove or any leading or trailing white space. So very nice, very easy, and execute the program. And there we go. Apples are looking much fresher because there's no space. There's no oxygenation going on, turning them yellow. Ah, right. Yes. Right. It's now a clean field, apples. So moving on, let's have a look. What's our next piece of data? Oh, there's something funny going on down here. What's going on here? Why have we got quotation marks in our string? We don't want quotation marks. We just want to know that a loaf of bread is priced at however much each loaf. EA for each. So let's clean up the string again. You remember last time we just stripped out the spaces. This time we're going to strip out the spaces and quotation marks. Yes. Did you know you could do that? You can have excuse me. You can have multiple characters that you're stripping out all in one go. So if you didn't know that little trick, there you go. I actually coded another way elsewhere, but we'll see if you spot it. Oh, right. So apples are still a nice clean field. That's good. Right, apples goes to so whatever we did, we didn't upset the stripping of apples. Then we have our each. So where's that? There it is. Okay, that's stripped out not only any spaces, but it's stripped out the quotation marks as well. So we're in business here. Oh, but look down there, lots of red ink. That's never a good sign. What's the problem here? What's wrong with this floating point number that Python is crying about? It's the $sign. Good. I hope somebody's telling you you're not giving all the answers, Jeremy. Right. So when we convert to floats, we're kind of assuming, and perhaps the title of the function is a bit wrong here. We're assuming it's a currency field. So perhaps there should be a second function, one convert to float and the other convert to currency or something like that. And as I said before, we shouldn't be using float anyway. So what we're going to do is, once again, I'm cheating. We're going to look for a currency sign, and if there's one there, we're going to get rid of it. And just for a bonus, if there are any commas, right? So if we have things in our supermarket which are worth more than $1,000, yes, every loaf of bread $1,000. Then we'll get rid of the commas if somebody has mistakenly put commas in. So, okay, we're feeling very efficient. We're feeling very clever with ourselves. And so let's run that program, see if it works. What's going on here? Right. So the currency field has changed. That's nice. Okay, we've now got a floating point value, 5.25. That's good. That's what we wanted. But what's going on here? And we've got problem with the product ID. Now you remember the product ID we're mistakenly changing into an integer, and it's got quotation marks around it. Oh, that sounds familiar. Well, we know how to solve the problem. Okay, let's dive back into the code. We're really good at this game. Okay, and there we go. We're going to get rid of the quotes, and then we will be able to convert to an integer quite cheerfully, won't we? Oh, yes, we're all optimists in this game. Let's run the program. And oh my goodness me. Okay, what's going on here? Right, the product ID is clean, right? So which one was it? Was it 105 or was it higher up? I can't remember. There we go. The 104 has been cleaned to 104. Thank you very much. No quotation marks. And we go on to the next row, the next record, and oh my goodness, look at all this red ink. What on earth is going on? What's wrong with this? Okay, our date doesn't match the format. Now, remember, I was very carefully telling you about formats of the date. So, once again, we've got those quotation marks. We're going to have to do something about that. Now, I'm going to cheat again because we could have quotation marks around the Y or the N of local deliveries. So I'm going to cheat. I'm going to do them all in one go. So there we are, cleaning up our dates by, excuse me, right? Clean up the dates by getting rid of the quotation marks and any spaces. And I'll cheat and do the same thing with the Boolean just to save a bit of time. Okay, let's see if he's as clever as he thinks he is. No. Oh, goodness, what's going on? Okay, well, we've got our Boolean working happily. We've got our date working happily. Good. Okay, so that's something at least, but we've got a load of red ink again. Could not convert string to float, kg. Well, kg is a pack size. Why is it trying to convert the pack size, that is the unit quantity, to a float? That just doesn't seem to make sense to me. Okay, let's have a look at our data. Here's the line of data that came in. There's our kg. Okay, all right. It's split up into these fields. Ah, right. Can you see the problem? We have an extra comma. Yes, well done, whoever. Flour, comma, wholemeal. And of course, our code is splitting everything at the comma. So instead of 6 fields, we've ended up with 7. And everything is 1 over. And that's why our kg is thought of as a price instead of as a units quantity. Oh, okay. Now, I don't know. This is just one error after another. And how many more errors are there likely to be? How many have we had so far? I mean, we're up to 13, and some people say that's the unlucky number. How many more are there? I know a lot of coders are very optimistic people, and we say, oh, there's only one more bug. Yeah, right. So, yeah, I don't know about you. I think I've had enough of this. Surely there's a lazy way to do this. This is just too much work for Mrs. Neal's little boy. Okay, and there is. You knew there was. What we're going to do is we are going to pull in the CSV library. This means that instead of opening the file and reading all of the lines, we are going to instead use what's called a reader. So think of the reader as a magic machine, a black box. That's fine. That's nice. And we'll be happy with that view. In this piece of code, just to show you what is happening, I will list what's happening in the reader. Now, the reader is a bit like a generator. It's certainly an iterator. It will give you back one row or one record of the file, one line of the file at a time. So I will convert it to a list here on line 28, and then we'll use Pretty Print to give us a nice result display on the right-hand side. And there you go. Well, look at that, right? All I have done is open the file, throw it into the reader, and the reader's given me back every single record just like that. Pop, pop, pop. Lovely, lovely stuff. Okay. What has the reader done? It's read the file, or it's read the records coming from the file, and it's parsed them. Parsing meaning to split up the individual record into its component fields. So it has understood the file. Okay, but once again, the results are all strings. So we're going to have to go back and pull in those formatting functions we were playing with. But I'm only going to use the basics of each of those functions. I'm not going to use some of the curly bits. Now, before we do, let's have a quick look at that last error. You remember there were too many commas. And you can see here that the reader has parsed the file correctly, saying, oh, no. That comma is in the middle of a field. It is not a separator or a delimiter at the end of a field. It is not separating one field from the successive field. Get it right, David. But that comma is part of the description that makes up the field. And it's worked. Oh, yeah, without, I was just trying to figure out how I was going to do it before, number 13, the unlucky number. I was thinking I was going to have to turn to something like regex, and that would solve all of my problems, wouldn't it? Right. Okay. You obviously figured out that I'm not a fan of regexes. Right. So strings, let's go back to those formatting functions. Let's see what we can do to improve life. There we go. There's the familiar functions. You can see here, I'm taking out some of the fancy stuff, just stripping them back to their basics, just to see, this the stuff which we probably don't need, but we did need when we were doing it all ourselves. So running that, and oh, wow, right. Okay, so the first thing is obviously I'm working with the entire file here. The reader works with the whole file at a time. And so we've got more than one row visible on the right-hand side in the execution window. Note how our comma is in the right place. Our field is regarded as complete. That's exactly what we want. Thank you very much. Notice that all the following fields, right? The kg is not being treated as if it is a float. It's being treated as a string, and our float is indeed being treated as a float. So, everything is working very nicely. Thank you, CSV library. Also, most of the post-processing's been eased. Right, so I took out a whole load of the fancy stuff from the functions, and yet everything's worked quite happily. So for our next iteration, let's tidy up the functions. Let's collate the fields into a class, right? So at the moment we have individual fields, individual identifiers. Probably not the best way to feed everything into the following processing, the actual business of our program, our imaginary program. Yeah, let's put it into a class just because we can, and because that's a handy way to communicate across an interface from picking up the file to actually working with the data. At the same time, we'll collect those results, because at the moment everything is just higgledy-piggledy on the right-hand side. So let's run the program without any further ado. And I don't want to run that. That's the class, right? Okay, getting ahead of yourself, David. So there's the class. All very familiar names down here on the left-hand side. Yes, I've used a data class because I could. Better than having separate values, keeping them all together, everything's hunky-dory. Here's our functions. Once again, they haven't actually changed, right? We are not actually messing with these functions. They're exactly as they were before. And here's the program. Let's run the program. And there we go. Right, so what have we done? We've created a product list. We have opened our file, we've run our reader, we're running through each of the fields. It should really be lines, not fields, shouldn't it? Naughty boy. And we're creating a class using those fields. So there we go. At the end of the program, we take that list of products, which we created back on line 27, and we print it out in a nice, pretty format. And so here it is on the right-hand side. Oh, well, that looks quite good. You can see why I used a data class. I'm lazy. I don't have to write the output routines. Okay, the product data class instance all collects into a list. Yes, we know that. CSV files. Now, some CSV files, remember I told you there's all these different dialects. Some CSV files start off with their first record is the headings. So it comes out of the spreadsheet program and it produces these headings because the headings were in the spreadsheet. So the people using the spreadsheet were using the headings to keep track of what on earth the data is all about. So if I try running that, we're going to be trying to do things like taking the words product ID and turning those into an integer. So we already know that ain't going to fly, Wilbur. So what we'll do is we will take in the data through our reader, and then we'll grab that first row. So I'm not messing around with the for loop here. I'm just taking that one record and putting it into headings. We'll print it out just to make sure we know what we're talking about. And then the rest of it is just exactly the same. So all we've done is put in one extra line. Now, some people say, all right, we'll have the for loop and we'll put an if statement into the for loop. But of course, anyone will tell you that's going to take time. So if we run the program, run the program. There we go. And I promised you that we would look at the headers, and there they are. Okay, right. To finish off, sorry, where was I? Yes. Is this the only way to read CSV files in an intelligent fashion? And the answer is no. We also have a dict reader. And you probably worked out already, the original reader was producing a list of fields. With a dict, we're going to somehow produce some sort of a dictionary. Let me just run this program so that you can see where it goes. And there we are. There's the last of the records. Locally sourced. Of course, these things are all in strange orders, but that's all right. Price set date. Those are the headers that we saw before on the last screen. And then the values are the values that have come in on the particular line. So there's our famous flower again. Those are the values that have come in. All right. Okay. So to close, the CSV reader will create a list of each row in the file, whereas the dict will create a dictionary of each row. So each field has its own personal label. So that's very nice. What can you do? You can work out how to take that dict output and put it into a class. You can also consider what would happen if we had data that was blank. Right? Will that work? Do you have that situation in some of your CSV files? Right? Is blank assumed to be 0 if we're talking about a numeric value? What does blank or what does a non-existent field mean? So there's a little challenge for you. In addition to readers, you'll be surprised to know that the CSV library has writers. The techniques that you use with writers are essentially the same as we've been playing with just now. Obviously, I'm running out of time, and so I won't be talking about them today. If you get the hang of CSV files, then you will find that there are additional mechanisms that you can use when you are using advanced libraries such as listed there. Roll your own. Seems easy. Yeah, I can code anything. Don't bother. Don't bother, right? Take a word from Uncle David. Lazy is good. Advantages over writing a custom approach to reading and writing CSV files. It's a lot simpler. See how short the program was. We didn't have to have all of those processing functions, formatting functions with fancy little twiddly bits. We got rid of a lot of that stuff. It takes care of the quotes for us. It escapes characters properly. For example, quotes inside quoted fields, commas inside the middle of a string, all those lovely little problems. You can also, with your different dialects, you can also change the comma into a semicolon or even a tab, right? So don't forget about TSV format files. That's tab separated values. And Unix, we often had DSVs, so colons and goodness knows what else we used. So there are all sorts of different dialects. So watch out for that. Error handling, yeah, okay, yeah, we're got to watch that one. Haven't dealt with it today, so you might like to see what happens if you only feed in half of the file. Yes, it's not going to work, is it? But see what happens. The other thing that the library copes with very well is cross-platform compatibility. All right, if you weren't already aware, things like the end-of-line character change between, in fact, right across from Microsoft to Apple to Linux or Unix. And when you want to use a writer, it will also adapt to that according to whatever you set or according to your own machine. It's fast. You saw how quick it was. There is a standard. If you're going to do a lot of work with CSV, if you're going to be creating files in CSV, recommend you read the standard. It's very short, but at least you'll be able to point to it and say, I'm following this standard. I'm following this convention. And is there anyone amongst us who is a master of Python or who is an expert in CSV who would like to say something, please? Some wisdom, some pearl of wisdom. No? Happy to accept all of that. Jolly good. Any questions?
All right, and our last speaker tonight is Ray Lutz, who's going to talk to us about PYON, Python Object Notation, serializing format for Python objects. Take it away, Ray. And you have HDMI?
Yes.
All right, should be good.
Okay, this should be a bit shorter since it's getting late. And you all have heard about JSON, JavaScript Object Notation. It's got some limitations. For Python, it isn't the best match. That's why I've discovered PYON. Now, it already exists. It's already supported in some respects by the standard library. And it's really pretty cool. Okay, so hold your you know, you're going to get excited here because this is pretty cool. Now, I made a really simple little library called PYON Tools because the main word PYON was not available, but it was from a package that shouldn't even use the name. So there are some other ways. So what can you not do with JSON that you'd like to do? You cannot use an integer as a key in JSON. All of the keys have to be strings. In JSON, you cannot use an integer. You can't use a none. You can't use a tuple. You can't use any of those as the keys. And you can't support sets. And you can't support tuples as an item. So there's some limitations. Also, JSON is just a pain in the rear for certain things, like if you put a comma at the end of your list, which is allowed in Python, but not allowed in JSON, and they don't like that. And also the quotes, right? It can't stand single quotes. So I didn't I sort of stumbled across this because
And it's kind of nice that David Neal discussed CSV, because I was using CSV library to spit out CSV records, and I had some fairly complex structures in there. Let's jump down to the example that I have. Okay, and maybe you can see this. So I import the PYON tools and some other things. Now the data I'm going to have is a dictionary with an integer key to start with. Maybe I'll make this even bigger. Integer key, a set, a tuple, a nested thing, and a thing with a tuple key. Those would be kind of nice to be able to save and recover. So what you would do is you could say PYON encode this, and you would get an output that looks exactly like what you're used to if you ask for this to be printed on your console. It already does this. It already prints this out in a nice format, and then it can be decoded and turned back into those structures. So here is the output of the first thing when we turn it into a string. And notice this quote at the beginning. That whole thing is actually a string, even though it looks exactly like the one that isn't a string. This one here is decoded into the structure, and you would say, oh, that's a dictionary, and this one looks like a dictionary, but it's not, it's a string. So they look exactly like what everyone is used to, no difference, and it recovers it very, very well. So here's where I actually stumbled across this. In a CSV writer, let's take an example. We're going to create what I call an LOL, list of lists. I use the LOL a lot, not laughing out loud, right? It's a list of lists, and it's like a square array in this case. And I have in the first row name and object, and the second row I have the word example, and then I have that same structure that we just had stuck all into one cell. So I have the structure in one cell of the array, and then I say, write that out into this buffer, and let's print it. It turns out it converts it for you. It puts that into the CSV file nicely, and then you can read it back in, and you get it back in, but as a string, as David said, this comes in as a full-on string. So you've got to decode that. Now, we don't want to use eval for decoding this, even though it would work, because that's very dangerous. It could have other stuff in there, functions and stuff, so we could sneak in. So there's a way to do it, which is using the what is it, AST library that guarantees that it won't run anything, so it's safe. It's a literal conversion. And that's part of the decode. So we take this object, which is this data, and here is, when we look at cell 1-1, right, we get this string. Okay, now it's not turned into an object yet, it's just that one string. And then we convert it and pretty print it, and you can see there it is in a pretty printed kind of with what pretty print might do for you. And then just to make sure to guarantee that the keys come back, I ask for the keys of the object, and it gives me, sure enough, the integer, the word set, tuple, and nested, and then that tuple, which is a key. Now you can't do this with the other libraries, like I thought that this really cool one called OR.JSON could handle integer keys, but it can't. It cannot. It converts it to a string. And if you already have a string value, which, like you say, string 1, and you have the number 1 and you want it to be different, no, sorry, it gets overwritten as the 1. So you cannot have string keys. There's a package called JSON pickle, which what it does is it doesn't use pickle, but what it does is it acts kind of like pickle in that it can put everything and make it look like it's JSON, but it isn't. You still have to have the other package to be able to convert it. So what good is that? So let's look at the list of comparisons here. PYON versus JSON versus Pickle. PYON is supports non-string dictionary keys. Pickle does. So, okay, what is Pickle? Pickle, as you know, is a library from Python that will store anything, but it's not human readable, which to me is a showstopper. I don't want non-human readable stuff. So non-string dictionary keys, that's not allowed in JSON. Set data type, not supported in JSON. Tuple, we already talked about those. Functions and classes references. Now, we don't want to actually have the thing that Pickle does, which is to have non-portable references. We want to have the name and the function name. So that's what's done here. We have the module and name is what we're doing. That's a little bit of an extra extension. Any object could be put in if the repr double underscore repr, I guess they call it a dunder repr, if that's available for your class and you can bring it back in with that, then you'd support it, right? It's automatically going to do that. Trailing commas are automatically allowed. Single and double quotes are allowed. Now, if you take a PYON string, which is the automatically generated stuff from Python, it's almost JSON. All you got to do is change the quotes to double quotes, and then if it's a dictionary, you're good. It will, so you don't have to go through and convert it into, an object and then change the object into JSON. That's a lot of work. So what I found is when I wanted to do this quickly, if I had a lot of records, like if you go into a database like SQLite, it can do JSON operations, but it has to be JSON, sadly. Sadly, they require the double quotes. If they didn't, if they were more Pythonic, then they would allow single quotes, and you wouldn't have to do that conversion. It would be very, very fast. And it is pretty fast anyway. If you just say, well, I know it's just a dictionary. I know that it doesn't have any weirdness in there. And so it's safe to just convert the single quotes to double quotes. Then it operates fast. Readability is super important. Pickle is just off. For me, I don't want Pickle because I can't read it. And in many cases, that's really important to have. Comments allowed, we decided to put that in. Cross-language compatibility, well, no. But Python can be converted into JSON easily, but you have to remember it has limitations. JSON doesn't do everything. Is it in the standard library? No, it's undocumented format. It doesn't, I haven't seen anybody talk about this. I haven't anybody say, yeah, there is a thing called PYON. So that's kind of what we have here. Now, I found that this is super useful because I know that if I have structures in my array and I write those out to CSV, they will be converted nicely into PYON. I have to know that it's PYON so that I can then change those quotes if I ever want to use it as JSON. I would like to push for support of PYON within all functionality in the standard library. Like SQLite should be able to support it. And why does this Python supported database not support that? That's a good question because it would make it work a lot easier. Enhance CSV writer to allow for compact mode. Now, right now it puts spaces, the glorious way. There's a comma, space, next value, comma, space is perfect, PEP8, compatible, but I don't actually want all those spaces in my database. I would rather have it be crunch format. And so therefore allow double quotes. And if you do that, it's automatically JSON. So if you say, I'm just going to put double quotes on my PYON and I'm going to not use sets or any of the other weirdness, then it's JSON without having to convert it really fast. Now, so that's what I was thinking is that maybe we would want to move this forward as sort of a project for San Diego. If you want to work with me on it, it's fine. It'd be fun because it would be a chance. We could make our mark in the world here, right? We can get PYON to be accepted by all of Python. now here's why I was getting into this. You know, I've been working on Daffodil, which is the data frames for Python using Python data types. And what I found was sometimes I had an array that was very sparse. Maybe the ones I was working on, it had 8,000 columns, but only really about 20 of them were used at any time. But all 8,000 were used sometimes. Well, it turns out if you put integers in there and leave blanks or whatever you want in this CSV file, it's always more efficient to just use one field and put a PYON dictionary in there or JSON. You know, you basically have a dictionary in there with the field name and what is in that field. So I have a list of just the 10 and not the 8,000 in that row. And so therefore I have this sort of indirect field. It was working good, and that's when I stumbled across this. So I thought I'd share it with you guys because you maybe, if you ever run across this, you really want to spit out a more complex field in your CSV file, or work with JSON in any way, and you say, well, I kind of need, I'll tell you the application where I really needed this. I have this, and I'll maybe present this at another time. This decorator that helps you write capture tests for any function. You put the decorator over your function. It has to be a pure function where there's not, more or less, but everything if possible goes through the function, right? The arguments, keywords, and then has a result. You don't want one that goes out to files and does a lot of monkeying around. It has to be pretty much a pure function. So the decorator captures all the inputs, runs the function, captures the outputs, saves that whole thing to a file, puts it in a nice format so it's like documentation. This is the function name. This is the doc string. This is what was put in. This is what came out. And then it's like documentation for how that function works. Well, what they need is something that will capture into a human readable format all the arguments, keywords, and results from that function. And so I was at a stumbling block there, and that's why I came across JSON pickle and all those other things. But it's easy to do. PYON will just do it easily. You just say, convert this to PYON. Python does it almost automatically. You almost don't have to even ask it. You say, actually, most things, if you do f string, quote, curly bracket, name of your thing in there, and curly bracket, and then it converts it exactly, and it's actually a string. That's what we're talking about. Okay, end of my talk. Any questions? Yes.
Do you see any implications of this in AI embedding of complex data like semi-structured or unstructured data?
Yeah, in fact, I was just talking to David when I was before the meeting, and some of these vector arrays, I guess, where you have in one cell essentially a list of many floats that you want to put into one cell. Well, you can put it into one cell without converting it to JSON or whatever you're doing, just by using PYON. And realize you don't have to use my library. It's very, very easy to do this. You just create the thing just by making the repr, put it in there, and then when you bring it back, make sure that you use the safe way to, don't have it right here, but they're in the code for the decoding. You don't want to use eval, but in that, just for safety. And there is a AST, abstract syntax library, that does the literal translation of that so that there's no way it runs a function. That's all I'm using. So I don't know the details, but I would love to know what, if people are needing to embed something more complex into, say, a CSV file or other structure like that, then it could be as complex as you want. But is it better than using JSON? I don't know. Depends on your application. I know that, like I said, in SQLite, they love JSON with the, this double quotes, no commas here and there and that sort of thing, and restriction on the keys. And so I have to convert right now when I want to do something in SQLite of a field that's JSON, or I want to split it up with SQLite functions, which are pretty good. They have a for each, so we'll go through each of one of those as JSON. If you don't have that, and I was talking to David here where he says, well, I just want to treat this 1,000 floats as one object in my data and have it decide which one is the best. It may be a good match. I just don't know. You know, it's just, this is where, I don't know if you're at this level. This is sort of a lower level of maybe, from what I saw, like this is not neural imaging. This is not, you know, AI speech recognition or that. This is actually, you know, Python coding at a fairly low level. But if you're, it's kind of a little bit of a higher level, right? Because we're not doing what David said. We're putting structures into the CSV file and how to represent it. Any more questions?
Actually, I should cut questions off, get in
Done.
touch after because we're out of time.
Understand. Okay, thank you.
Just a quick question.
No.
Just a quick comment. Can you have an example for your case? Let's say that, you know.
Okay, let me talk to you at the end. Okay, thanks.
All right, thank you for coming. Yeah, we should be out of here relatively soon, but thank you for coming. Thanks to our speakers. Thanks to Qualcomm, and thanks for Neo4j. Thank you.